We're doing 2.3 day 2 trigonometric and higher order derivatives. So example 1, find k prime of x using the quotient rule of k of x equals 2x plus 5 over 3x. So remember, the quotient rule is the derivative of the first or the first, so times the second minus the derivative of the second times the first, and it's all over the second squared. So all you have to do after that is find the derivatives and simplify. So the derivative of 2x plus 5 is just 2 times 3x minus the derivative of 3x is just 3 times 2x plus 5 all over 9x squared. And then you just simplify. 2 times 3x, 6x, minus distribute, so minus 6x minus 15 all over 9x squared. 6x's cancel, so you have negative 15 over 9x squared. If you simplify, since they both have a 3 in common, you'd get negative 5 over 3x squared. And that would be k prime of x. So the next thing you have to do is find the derivative of secant x using an identity and the product rule or quotient rule. So secant x is really 1 over cosine x. So you're really finding the derivative for that. So that's your identity. So the derivative of 1 over cosine x. So if you do the quotient rule, it's the derivative of the first times the second minus the derivative of the second times the first all over the second squared. So if you solve that, the derivative of 1, since it's a constant, it's just 0, and 0 times cosine is still 0, minus the derivative of cosine is negative sine of x, and it's just times by 1, and it's over cosine squared of x. And then 0 minus a negative, it's plus, so it's positive sine of x over cosine squared of x. And then if you split this up, sine of x over cosine of x times 1 over cosine of x, you get, this is tangent x times, and then this is secant x. And then that's your derivative for the secant x. So if you look here, the tangent function, if you derive it, it's secant squared x, and then the derivative of secant x is what we just found, tangent x times secant x. For exercise 3, it wants us to find y prime, so it wants us to find the derivative of y. So for the first one, it's secant x over 1 plus tangent x. So you want to find the derivative of the first times the second minus the derivative of the second times the first all over the second squared. And so derivative of secant x is tangent x secant x times 1 plus tangent x minus the derivative of 1 plus tangent x. Derivative of 1 is 0. Derivative of tangent x is secant squared x. So that's all over 1 plus tangent x squared. So the next thing you do is simplify the thing first. So tangent x secant x times 1 is tangent x secant x plus tangent x secant x times tangent x is tangent squared x secant x minus secant squared x times secant x is secant cube x. Still all over 1 plus tangent x squared. So the next thing you can do after this is factor out a secant. As you can see, all of them have a secant. So after you look at this, you can see that there's an identity in here for tangent squared x minus secant squared x. It relates to the sine squared x plus cosine squared x equals 1 identity. And so if you just divide all of them by cosine squared x, you'll see that you could get tangent squared x plus 1 equals secant squared x. And if you just rearrange it, you'll find a way to make that work. So if you subtract secant x squared on both sides and 1 on both sides, you can get secant squared x on that side and you'll have a negative 1. So you can see this is the same thing as this. So if you have tangent squared x minus secant squared x, you can put negative 1 instead. So you have secant x times tangent x minus 1 all over 1 plus tangent x squared. And that's your final answer. It could come in different forms, but this is one of the equivalents. So for the next problem, part B, it wants us to find a derivative for 1 plus sine over cosine x. And so I'm going to do it on a separate sheet of paper since this part is filled. So we're going to do the same thing we did for the first one. So I'm going to do the quotient rule. So the derivative of the first times the second minus the derivative of the second times the first all over secant squared, so that's cosine squared. So the derivative of 1 plus sine x is just cosine x, because 1 is a 0, times cosine x minus the derivative of cosine x is negative sine x times 1 plus sine x all over cosine squared x. So Next thing you do is simplify it. Cosine squared x minus a negative is plus. And so if you distribute, it's sine x plus sine x squared all over cosine squared x. And if you rearrange this to be cosine squared x plus sine squared x plus sine x all over cosine squared x, you can see that there's an identity here, and that just equals 1. So it would be 1 plus sine x all over cosine squared x. And you can simplify that a little bit more, because cosine squared x can be from the identity so cosine squared x could be 1 minus sine squared x. And if you just split that apart, it'd be 1 plus sine x times 1 minus sine x. So that's the same thing as that. And so you can cancel out 1 plus sine x over 1 plus sine x because that's just 1. So you're left with 1 over 1 minus sine x as your answer. Go on to the next problem. Exercise number 4. It wants us to find the equation of the tangent line at the point of pi over 4 to 1 for part A. So what you want to do is find a derivative. Let's find the slope, because remember the point slope form is y minus y1 equals the slope at that point times x minus x1. You already have your x and you already have a y. So you just have to find a slope at the given point. So dy dx, the derivative of tangent is secant squared x. You plug in your x, so secant squared at pi over 4. So that's secant squared is the same thing as 1 over cosine squared pi over 4. And cosine at pi over 4 is root 2 over 2. It's squared. So you'd get 1 over 2 over 4, which is really 4 over 2, which is 2. So that's your slope at that point. And if you put it in point slope form, so y minus the y you were given equals the slope times x minus the x you were given. And that is your tangent line for A. And for B, you're going to do the same thing. The only difference in this one is it's a product rule. You have to use a product rule for this one to find its derivative and slope. So the derivative at x equals pi equals to the derivative of the first is 1 times the second, so it's cosine x, plus the derivative of the second, which is negative sine x, times the first, which is x. That equals to be cosine x minus x sine x. And all you have to do after that is plug in the x. So cosine pi minus pi sine pi. Cosine of pi is negative 1, if you think about the unit circle. And then sine of pi is 0, times pi it's still 0. So your slope is negative 1. And for point slope form, we were given the y of negative pi, so y minus negative pi is y plus pi equals your slope times x minus pi. That is your tangent line at cosine x times cosine x at pi, negative pi. And then for C, still do the same thing.